In this video, we will discuss about the energy sources. In order to perform a work, we need energy to do it. All living organisms require energy to stay alive, just like humans get energy from food. Energy is defined as the source of change, the ability, or the capacity to effect change. The sun is the source of energy for most of life on Earth. In electrical terminology, energy source is defined as a device that generates electrical energy. We use different energy sources to power our TVs, computers, cell phones, and etc. We also use energy sources in cars, planes, trains, and many more. There are two types of energy sources: independent sources and dependent sources. Now we will talk about independent sources. The output of an independent source does not change by any kind of variation in the network. Independent sources actually exist as physical entities, such as battery, or a DC generator. They are further classified into two sources: voltage source and current source. An ideal voltage source has the absolute constant voltage, with whatever be the output current. It has zero internal resistance, and the power drawn by the source is zero. Whereas, a practical voltage source has some internal resistance, and the voltage is not always constant. An ideal current source produces constant current, irrespective of the voltage across it. It has infinite resistance, and is capable of supplying infinite power. Whereas, a practical current source has some internal resistance, and the current is not always constant. Now let's see the dependent sources. The voltage, or current of the dependent sources, is not fixed. It depends on the voltage, or current of some other parts, in the circuit. Dependent sources are used to represent electrical properties of electronic devices, such as operational amplifiers, and transistors. There are four possible dependent sources. Voltage-dependent voltage source, VCVS. Current-dependent current source, CCCS. Voltage-dependent current source, VCCS. Current-dependent voltage source, CCVS. Let us see them in detail. Voltage-controlled voltage source, VCVS. This is a voltage source whose output can be controlled by the input voltage. In this source, the output voltage is directly proportional to the input voltage. We can also write it as: here K is proportional constant. VCVS is also called as the voltage amplifier. Here, K is also called voltage gain of the amplifier. The ideal VCVS has an infinite input resistance, and zero output resistance. Let's see current-controlled current source, CCCS. This is a current source whose output current is controlled by the input current. That is, the output current is directly proportional to the input current. We can also write it as where K is a proportionality constant. CCCS is also called current amplifier. Here, K is also called the current gain of the amplifier. The ideal CCCS has a zero input resistance, and an infinite output resistance. Now, let's see current-controlled voltage source, CCVS. This is a voltage source whose output voltage is controlled by the input current. That is, the output voltage is directly proportional to the input current. We can also write it as where Rm is a proportionality constant. CCVS is also called transresistance amplifier. Here, Rm is also called the transresistance of the amplifier. The ideal CCCS has zero resistance for both input and output. Let's see voltage-controlled current source (VCCS). This is a current source, whose output current is controlled by the input voltage. That is, the output current is directly proportional to the input voltage. We can also write it as. Here, Gm is a proportionality constant. It is also called transconductance amplifier. Here, Gm is also called the transconductance of the amplifier. The ideal CCCS has infinite resistance for both input and output. In this video, we have discussed about the sources of energy.